Now we haven't been estimating the last few questions because we've got 3 methods to check our answers against. But we'll just estimate to begin with so that we know the kind of answer that we'll get, because now we've got a negative number involved. So we've got negative 3.4 adding on 1.5. In a really basic sense, we know that we've actually got a larger negative number here than the positive side of things, which means our answer is going to be negative. So we need to make sure that that's the case every single time. Okay, on the number line, because I'm working with a negative number as my starting number, I'm going to need to put 0 over here somewhere. And I know my answer is going to be negative, so it looks like I'm going to be sitting over on the negative side of my number line. We're using the unscaled idea, so I will start with negative 3.4, and I don't mark in all my scale. I'm not going to worry about that. I'm going to move to the right, that's what addition tells us, by 1 whole and then another 0.5. So I move 1 whole in this direction. So it was negative 3.4, now I will be negative 2.4. That's the 1 whole. Now I need to move plus 5. I'm at 2.4. I could move 1, 2, 3, 4, and I would be at 2. And then but I had to move 5/10. I've only moved 4, so I've got to move 1 more. That would be negative 1.9. So that's actually my final position. Just move 0.1 there and 0.4 there, and that's where the 0.5 is coming from, and that is the 1. So we move by 1 and then 5 more tenths. You can see it's starting to get quite difficult on the number line. So as the numbers get more complicated and the operations, or not the operations, beg your pardon, the type of numbers become more complicated, the number line gets harder to use. But we have got an answer of negative 1.9, so we'll keep that as our final position over here. Let's move to the algorithm. When negative numbers are involved, the algorithm too becomes a little bit more complicated, and there's a bit of thinking before you can use it. So I'm just going to write down negative 3.4 plus 1.5, just copying down the question. I'm going to rearrange this because I've actually got 2 numbers that are being added together, and the commutative law says that we can add 2 numbers in either order. So I'm just going to keep the negative number in brackets so we don't think it's a subtraction. Now I do know that when you add a negative number, that's the same as subtracting. 1.5 subtract 3.4. So that's why we're suddenly dealing with a subtraction, because we're adding a negative. Even when it was out here, we're still adding on a negative number. And the reason why we do all that is because subtraction can be takeaway, but it can also be thought of as the difference. And we're looking for the difference between our 2 numbers. So if we know that subtraction is difference, we're actually going to subtract these 2 numbers, and our algorithm must have the larger number on top, so 3.4 and 1.5. And if you're thinking, hold on, isn't that number negative? You're right, we're going to take care of that later, but the algorithm cannot deal with negative numbers. So instead of trying to put negative 3.4 into an algorithm, we're thinking of 3.4 as some kind of subtraction, and it's a difference. So let's do that. We're going to take 5/10 from 4/10. I can't do that. I need to rename. So I'll take one of these wholes, leave 2 there, and I'll rename my whole as 10/10, plus I've got the 4 there. So I've got 14/10. 14/10 take 5/10. I can do that. That's 9. 2 take away 1 whole is 1 whole remaining. Now I know that I was a bit sneaky here. I ignored the fact that 3.4 was negative. So you can use the algorithm, but you've got to do a little bit of extra thinking. That's when we go back to our number sense and we look at where we started and we know the answer will be negative. 3.4 has a larger size in the negative direction than 1.5 does in the positive direction. So our answer must be negative. So even though the algorithm doesn't show that, the extra thinking that we have is actually going to add in that we're aware that the answer is negative, even though the algorithm was not able to produce that. And that certainly agrees with our number line. In fraction form, it's not too bad at all. We work very similarly to how we have in the past. Negative 3.4 becomes negative 34 tenths. And that negative number can sit with the numerator. 1.5 can be rewritten as 15 tenths. And then it's a case of adding those together. So negative 34 tenths plus 15 tenths. Remember, if the denominator is the same, we're going to add these. Negative 34 plus 15. And so that's a mental calculation. I guess you could do it in a similar way to the algorithm. And you will get negative 19. More baddies than goodies if that's the way you work with it. My denominator is 10, and I can rewrite that as a few different ways. What shall we do first? We'll put the negative at the front, negative 19 tenths. You don't have to do this many steps. And then we know our answer is negative. I've got one whole here and 9 tenths. Or I could say negative 1.9. And again, we've reached the correct answer every time. So have a think about which way you think will work best for you, which is the most reliable and makes the clearest sense, so that reduces the errors that you make and increases your accuracy.